Hi, and welcome to our Rubens Tube experiment. We are with Diego Martinez, Diego Morales, Santiago Chavez, Diego Pando, and Christopher Calora.
So the topic that we'll be explaining on today is sound. So sound are basically composed of longitudinal waves where the molecules vibrate and move parallel to the direction of the wave. And so these, they depend on the medium to see which speed they're traveling in. Like in fluids, it depends on the bulk modulus and the density. In metals, it depends on Young's modulus and density. And in gases, it depends on the adiabatic constant, the pressure, and the density as well.
Okay, now, standing waves in form of tubes that the open tubes make all the harmonic frequencies and the closed tubes make only odd frequencies. Now, some characteristics, a characteristic of the sound is the frequency. Now, the frequency determines the pitch, that is the audible range of 20 Hz to 20 kHz, and intensity, which relates to volume and is measured in decibels.
Okay, the materials we use for this experiment is one can of 35 milliliters, and the speaker of the cell phone, a screw, a lighter, a balloon, and cardboard for the base.
Okay, so now the explanation of the project. The experiment consists in a tube that is sealed at both ends and filled with a flammable gas. A speaker is attached to one end of the tube to transmit sound waves through the gas mixture. Small holes are drilled into the top of the tube, and when the gas mixture emerges, it creates a flame. Okay, so here we have our project. Here we can see the small holes and the balloon, and here we use a catheter for the gas to pass through to the bottom.
Now we're going to talk about the calculations that we use for this project. As you can see on the image on the video, you can see that we had the speed of sound in gas, the wavelength, and the frequency. To have the speed of sound in gas, we have to search about the molecular mass of propane, which is the gas we're using to it for light up. We have to use the temperature and two constants that we already knew. So, as you can see in the image, velocity equals the square root of these three things I told you over the molar mass, which gives us 252.3105 meters over seconds. Now for the wavelengths, we just need to multiply 2 times the length over the number of lengths. So the length of our can was 0.11 meters. So it would be 2 times 0.11 meters over 1, which will give you 0.22 meters. And for the frequency we get it 1 times the velocity over 2 times the length. We have the velocity, which is 152.3105, and our length, which is 0.11 meters. So, as you can see on the image, we multiply it, and the result is 1146.1659 Hz.
This will be all for our part.